Okay, in this video we are going to talk about non-homogeneous ordinary differential equations. We are going to start one example of non-homogeneous second order differential equations. So we are going to use the first method. Of course, you know we have two methods of solving non-homogeneous second order differential equations, that is undetermined coefficients and variation of parameters. But in this video we are going to talk about non-homogeneous undetermined coefficient method. So we're going to see one example here. So we have second derivative minus twice first derivative is equals to 8. This one is 8. This one over here is 8. Exponential x cos x. And let's assume actually an educated assumption of its solution to this first part. We are going to start with this first part and we are going to equal to 0. So we have an assumed solution to be y of c is equals to exponential lambda x. Now we differentiate twice. As you know, we have two constants here. So we have a constant 1 here and we have another constant which is 2 here. So we are, of course, with this enough instructions, we have to differentiate it twice. So we differentiate the first one. We have y of c is equals to lambda exponential x raised to lambda x. Then we differentiate second. We have lambda square e lambda x. So with all this, now we can input these all values into our equation over here. So we have this one, lambda squared e exponential lambda x minus, this one is minus, twice vast differential. And we have this one, we factor out exponential lambda x and we equal it to 0. So but we know that exponential of something can never be 0, so we have only one part of the equation which must be 0 in this case, which is lambda squared minus 2 lambda. So we equal that one and we have finally our solutions to lambda 1 and lambda 2 to be 0 or positive 2. Now let's continue to see the final equation, which is y of c, c1 exponential 1 x, which is our first one, which is 0, and we have the second, which is lambda 2, and we input both of them. This one is 0x, so exponential of something must be 1. So we have our final equation to be y of c is equal to c1 plus c2 exponential 2x. Now we proceed with the next part of our equation. We are going to solve this other part here, 8 exponential x cos x. We also have to assume a solution, an indicated solution. In that case, let me use that word. If at all you guys we have that assumed solution actually. So y of b a e x cos x plus p of x x sin x. So that is our assumed solution to this side, h e of x cos x. Now we differentiate this. We did the other part of the equation, this other part over here. We also have to differentiate it twice as per that instruction. So we differentiate first one here. So we have ae cos x, b exponential x. So we start with this with product rule. We have ae exponential of course cos x and then aex sin x. So that's the differential of that part, and then we also differentiate bx, so that we shall have bex sin x plus pex cos x. So now we collect the like terms over here. We have cos and we have cos also over here. So we bring them together and we shall have the solution, aex plus bex x cos x plus bex minus aex sin of x. Now we proceed to differentiate it, second derivative over y of b. So we differentiate this part. We have aex over here cos x minus aex sin x minus the differential of this side AEX sine x minus AEX cos x. Now we proceed to differentiate this other side. We have PEX sine x, PEX cos x minus PEX sine x. So when you collect all these terms, we shall have this AEX over here cancelling with this other AEX cos x over here. So we cancel that one. Also we have BEX sine of x cancelling with this negative over here, BEX sine x. So this one cancel. So we are remain with this one and this one and this one. So when we collect them, we have twice PEX cos x minus 2 AEX sine x. Now we proceed. Now the same thing we did over here, by after having the both differential, we now insert on our original equation. We also do with our y of b, and we shall have 2BEX 2 exponential x cos x minus 2 exponential x sin x minus twice the second batch, this one. So finally we shall have our equation to be, okay, let me shift a little bit, guys. Let me bring my camera. Right, and now we are good to go. Now 2BEX minus 2AEX minus 2BEX cos x minus 2AEX minus 2BEX plus 2AEX sin x. So we have collected the like terms over here, and finally we shall have this one and this one cancelling, left with this one and also this one cancelling, and we are left with this part. Now we have the last part of our equation now, which is the last part of our equation y of b, which must be equal to our initial equation 8e x cos x. Now so we equal it to it, and we shall have this side over here. So we shall have AEX cos x. Now when we equal this side with this other side, we have to introduce an imaginary value of sin x to the other part of the equation, so that it can be equal to our sign over here. So when we equal both of them corresponding parts, we have a exponential x of cos x must be equal to 8e exponential x cos x. Now we divide, we equal them, this one, then we shall have a to be negative 4 and 2b is equal to 0, b is equal to 0. Now we shall have now our final equation to be AEX cos x plus BEX sin x. So no, with all these values over here, all this calculation, we were trying to find for the values of a and b only in our general predicted solution of the equation, the particular solution of that equation. So now we have all of them. So we have our final equation now to be AE of x cos x plus b exponential x sin x. So that one will simplify because we already know the value of b to be 0. So this one will disappear, and we are left with y of b is equal to a little bit to be y of b is equal to negative 4 exponential of x cos x. Now our final solution now will be the sum of y of c plus y of p. Y of b, here we have it, and y of c, we had y of c over here. We have y of c over here. So y of c is c plus c2 exponential of raised to 2x. So we sum them and we have a final now answer to be c1 plus c2 exponential of 2x minus 4 exponential of x cos x. So that is our answer. And have a nice day.